So, first thing, I had made a second video earlier today and I caught a flaw in it. So, I need to remake this video. As a reminder, in our first video, we had shown that the mean of the sampling distribution of sample proportions, that's this object here, is equal to the population proportion, and we had shown you that the population proportion was a half. Now, we are going to do two things here. I don't know why I can't get that to move. There we go. All right, so what I'm going to show you now is that I'd forgotten to do this one piece, so I got to call up another Word doc. There we go. Come on. There we go. Here's a new document. All right, so we know what the mean is, and we're dealing with the population with two objects in it, a head or a tail, and that will mean that to get the standard deviation of the population, we're going to take, and there's really two ways to think about this formula, and I'm going to touch on it again in a minute, but basically what's going to happen is we're going to add up each potential random variable x minus the population mean, and we're going to square that. And if we divide by the population size, that is the same as multiplying by, I'm going to delete, 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 and delete. That is the same as multiplying by the probability of that random variable x, because we have a 1 and we have a 0. There are two objects, 1 and 0, and the probability of a 1 is 1/2, and the probability of a 0 is 1/2. The probability of 1, we're talking about the heads, and we're talking about the tails. So we can either get a head or we can get a tail. And so they happen 1/2 of the time, and since there are two options, the n would be 2, and what occurs is we can just say it is the probability of the random variable x. So what this is going to look like is the square root of 1 minus a half squared multiplied by a half plus 0 minus a half squared times a half. Now, what this will be equal to is the square root, and so this is going to be negative 1/2 squared, and when you square it, you're going to get 1/2. I'm sorry. When you square it, you're going to end up with 1/4. Yep, that's right, 1/4. So this part becomes the 1/4 after you square it, and then you're multiplying it by a half. And this piece in this set of parentheses is going to be negative 1/2, but since we're squaring it, negative 1/2 times negative 1/2 is a positive 1/4 times a half. Now, we're going to have the square root of 1/8 plus 1/8, which is the square root of 2/8, which is the square root of 1/4. And when you take the square root of a fourth, you get a half. Whoops, that's supposed to be a half. Now, I'm going to delete this. I just showed you that the population standard deviation is a half. So, there. So our population standard deviation is also a half. Now we are on a quest to determine what is the standard deviation of the sampling distribution of sample proportions. All right. So again, I'm going to point this out. So if we're talking about the standard deviation, it is the square root of the sum of each data point minus the mean squared divided by capital N, the number of things that are in the population. Now, we can put the probability there because the way the probability works is N is our total number of objects, and in this sampling distribution we're going to have a total of 8 objects if you count across. 1, 2, 3, 4, 5, 6, 7, 8. And the numerator is the number of paths that fit that description. So it just works out to be the probability. Now, let me point this out. So for the number of, if you want all heads, that's 3 out of 3, but there's only one path that has that. And so 3 out of 3 is 1, and then you subtract the mean, and there is only one path that has that. That's why it's 1 out of 8. And then you have the probability of, you have the 3 tails, which means no successes, so your proportion is 0 out of 3. That's a 0 minus a half, and there's only one path that gets that. That's why it's 1 out of 8. Now the other two, the 1/3 option and the 2/3 options, occur 3 times each. That's where this 3 out of 8 is coming from. If you look, you have the 1/3, you have the 1/3, you have the 1/3. There's 3 out of the 8 paths. You have the 2/3, you have the 2/3, you have the 2/3. That's 3 out of the 8. Now, the 1/3 minus a half and the 2/3 minus a half give us a negative 1/6 and a positive 1/6. So let me just do a little bit of scribbling here and show you how I got there. So I have 1/3 minus 1/2, and this one's going to get me the negative 1/6. I'm going to have to get a common denominator, so I'm going to convert the 3 and the 2 to 6. And what do I multiply 3 by to get it to 6? I multiply it by 2, so I have to multiply the top by 2. So 2 times 1 gets me my 2. What do I multiply 2 by to make it 6? 3. So I'm going to multiply the top by 3 as well. And so I have 2 minus 3, giving me my negative 1/6, which is in there. I do the same process here, except the 2/3 will end up giving me a 4/6, and then the 1/2 will give me a 3/6, and so I end up with 1/6 in there. Now, I'm going to square this. I'm going to get 1 over 36. I'm going to square this. 1 over 36. I'm going to square this. I have 1/4. I'm going to square this. I have 1/4. I did that out of order, so I apologize, but we were focusing here and focusing here, so I just kept the focus on that. Now, I'm going to multiply these two together, multiply these two together, so they're both 1 out of 32. I'm going to multiply these two together and these two together. I'm going to have 3. The 3's will reduce, forgive me. I'm going to do the 3 into the 36 and get 12. So I'm going to have 1 over 12 times 1 over 8. 1 over 12 times 1 over 8 again. So I'm going to have 1 over 96. Okay, so let me push this aside and pull this forward. So I've got 1 out of 32, 1 out of 32, 1 out of 96, 1 out of 96. And so I'm going to end up having 2 over 32, which reduces to 1 over 16. I'm going to have 2 over 96, which reduces to 1 over 48. Getting a common denominator. So multiply by 3, multiply by 3. So I have 3 over 48 plus 1 over 48, which becomes the square root of 4 over 48. Now, I'm trying to head to this formula here. And I have to remember that Q is the same thing as 1 minus P. So you can think about it as 1 minus P, you can think about it as Q. Don't get too stressed by that. So I have 4 over 48 underneath the square root. So I'm going to break this up. I'm going to write it as 4 over 3 times 16. This 4 will knock this 16 down to a 4. So I have 1 over 3 times 4. Now, don't write it as 12. Keep it apart because I'm trying to head somewhere. If you had 1 over 4 divided by 3 over 1, what you would do is look at it as 1/4 times 1/3. I'm going to remind you that when we divide fractions, we convert to multiplication and we take the second one and we flip it. And so this one's really 1/3. So what I'm looking at is 1/4 times 1/3. Well, this is 1 over 4 times 1 over 3. The ones are just combined. And I'm breaking it out because I'm trying to head to having the sample size in the denominator and having the P and the Q, or the 1 minus P, in the numerator. Well, I have 1/4 up top, and I can break that apart into 1/2 multiplied by 1/2. Well, that is the P, that is the Q. Okay? So I have my 1/2, I have my 1/2, and I have my sample size. Now, when I take the square root of, well, I don't need to take the square root, ignore that. I end up getting to the formula, which is the square root of P times Q over N. And what I end up with is really actually our third z-score formula, where it is P hat minus P over the square root of PQ over N. All right. Now, how does that help us? Or how does that impact what we're doing? I'm going to delete this off. I'm going to delete this off. Let me bring this forward. And so first of all, just as an example, the soft drink cups at a certain fast food restaurant have tickets attached to them. Customers peel off the tickets to see whether they win a prize. The proportion of tickets that are winners is 0.25, and a total of 70 people purchase soft drinks between noon and 1 p.m. on a certain day. Let P hat be the proportion that win a prize. Find the mean and the standard deviation of P hat. Okay, so our population proportion is 0.25. Our sample size is N. So to get the mean of the sampling distribution, we just take the P from the population, which is 0.25. To get the standard error of the proportions, what we do is we take our P, we take our Q, or 1 minus P, and we divide it by our sample size. So this piece here is nothing more than our population proportion. And we use it in our standard error as well. So here's our P, here's our 1 minus P, and then here is our N. And that is the standard error of the proportions. Okay. That's a little bit. It's not done yet. Let me turn this and delete that. And let's grab the next problem here. So, the National Center for Educational Statistics reported that 82% of freshmen entering public high schools in the U.S. in a recent year graduated with their class 4 years later. A sample of 135 freshmen is chosen. Find the mean. Okay, so mu sub P hat. All right, well, mu sub P hat is going to be 0.82 because we're just taking the value from the population. Find the standard deviation. Okay, so standard error is just another name for the standard deviation. And what we do is we're going to take the 0.82, and then we're going to subtract 1 minus 0.82. So I have 0.882 times 0.18. And then we are dividing by 135, and this is all underneath the square root. Now I will point something out. Before we do this, we should be checking to see if both n times p and n times q are greater than or equal to 10. So if they're smaller, if either one is smaller than 10, what we actually have to do is build the binomial probability distribution completely, and then to answer questions we have to work off of the binomial probability distribution. Okay, so we're assuming that these are greater than 10. Okay. Now, find the probability that less than 80% of the freshmen in the sample graduated. Okay, here is where, and I'm just going to cross this out, ignore this piece, because I did a cut from a book and posted it. So here's what we're going to have. We are going to have to realize that what we're doing is we're actually getting a z-score, and our p hat is our proposed sample size, so that's going to be 0.80. Now our proportion that we got for our population was 0.82, and then we have this square root of 0.82 times 0.18 divided by the 135. Now, this is going to be a z-score. If I'm typing it into my calculator, I have to be careful and put that in parentheses. Let's make sure I've got the right calculator. I do not. Hold on one second. So, what I'm going to do to get that z-score is I'm going to put in parentheses the 0.8 minus 0.82. That's all in parentheses, and then I'm going to divide it by second the square root. So when you type this in, make sure that this entire expression is inside your square root. And you can do that by putting it all in parentheses. So 0.82 times 0.18 divided by 135. We hit enter, and we're going to get a z-score of negative 0.6048. All right, so if I'm thinking about this in terms of trying to describe it, what I'm doing is I'm taking the z-score. Here's where my z-score is 0. I'm at negative 0.6048. So here's my negative 0.6048, this spot. And I'm trying to do less than, which is all the area to the left of that. So a way to do this is to do the second key and then the vars key. And then you're going to find normal CDF, which is number 2. Now, if you have an old calculator, all you're going to see, and I'm cutting out ORML, so I'm just doing NCDF. And what you need to do is you have to do the lower value or the left value, the upper value. So here's your lower, here's your upper. This is where your mean is going to go, and here's where your standard deviation is going to go. Well, for us to look at this graph this way, we're going to say, oh, look, it's negative infinity. We don't really have a negative infinity button on our key, so we do negative. Remember, negative is below the 3, and we just put a 1 with a bunch of zeros. Okay, I'm going to try and fit in 100,000. My upper is going to be negative 0.6048. My mean is 0 and my standard deviation is 1 because I'm on the standard normal curve. Now, that is one way to type it in. And when you do that, negative 0.6048, 0 and 1. We've got to hit enter a couple of times, and we get 0.2762726. So there's basically a 27% chance that you're going to have less than 80% of the freshmen have that happen. Now, you can do this another way. You can do normal CDF, so second vars normal CDF, and you can work in raw data, but you just have to be careful how you do this. So if you're going to work in raw data, you're going to go still negative 10,000 or negative 100,000. And then the left value is 0.80. And then the mean is 0.82. Here's where you have to be careful, though, because you can't just take the population standard deviation. You have to take the adjusted standard deviation. So you've got to fit in here the square root of the 0.82 times the 0.18 and then over the 135. So you don't end up having to do the z-score formula, but you still have to address the fact that you're in a sampling distribution of sample proportions. And the way you do that is by making sure the standard deviation is not just the population standard deviation. Okay, and if you do that, you should get 0.27. I'll just do it quickly. So second vars, normal CDF, negative 10,000. Actually, I've got negative a whole lot of, a 1 with a whole lot of zeros, then 0.80. And at the mean spot, put 0.82, and then at the standard deviation, you're going to introduce the square root. You're going to put 0.82 times 0.18 divided by 135, making sure to close that off so that the whole set of parentheses is in there. All right, and then go to paste, and then hit enter, and you get the same value of 0.2726 and so forth. So just be careful with this component, because that's what tells the computer whether you're working in just a single item or if you're working with a sampling distribution. All right, so how do we deal with this one? Well, it's easier typically to work in the environment where you just take the raw data points. So our left one will be 0.75 and our right one will be 0.85. And then you have the 0.82 and your standard deviation. Okay. For letter E, it's the probability that more than 75% of the freshmen in the sample graduated. Well, your lower would be the 0.75 in this instance, and your upper would be off to infinity. So this time you're going to put a 1 with a whole lot of zeros, and then the 0.82, and then the standard deviation. Okay. Would it be unusual if the sample proportion of students who graduated were more than 0.90? All right, so normal CDF, our left is 0.90, our upper is 1 with a whole lot of zeros. Then we do our 0.82, and then we do our standard deviation of the sampling distribution of sample proportions. So 0.82 times 0.18 over the square root of 135. Okay, so we go second vars, normal CDF. Our lower is going to be 0.90. Our upper is going to be 1 with a bunch of zeros. Okay, then we put our 0.82, and then we put our standard error, and we hit enter. And what we get is 0.007. Now, this is smaller than or equal to, it's really smaller than, but we have to put the or equal to 0.05. This is the threshold to indicate if something is an outlier, something is unusual. So if the probability is smaller than 0.05, it is unusual. Okay, so it's an indicator that getting this value or something higher than that is an outlier. It's unusual. Okay, I hope that helps. Have a good one.